Hi guys, today we're going to be talking about math and specifically number theory. And more specifically, we'll solve my number theory using geometry. So I'm sure those who are interested in math or who have ever tried to get into that, they've seen this question before. Is square root of 2 rational? And I'm sure many of you have seen the proof, and the proof itself is relatively easy. But today we're going to be covering something else. We'll prove this question by using geometry. So let's get started. The main point is that we need to understand what that means for a number to be rational. And actually it means that we can express it as a ratio of integers that cannot be simplified basically. And that's why we're gonna be solving this question instead. Can square root of 2 be expressed as p over q, where p and q are irreducible numbers? Or in a simpler language, they cannot be divided by the same number. And let's simplify the question a little bit more. And this equation is actually what we want. Even though it looks like a bad drawing, but mathematically we can express it as which basically means and which actually means this is our goal. So how can we use geometry in order to show that this thing is impossible? So now you watch me drawing the basic sketch. So here I'm trying to overlap those small squares in the big square with the sizes provided. And yeah, I hope the picture is clear enough. So let's get the part we're actually interested in. As we see, our two squares, initial squares, they intersect in this part, right? And in the main square, in the picture before, we got two gaps, those two squares. So, and basically, this gets a little bit tricky. So, in order to the initial two squares to be equal to the area of the initial big square, we need this area, or like this square, to be equal to the sum of the areas of this square and this square, which is basically the initial problem we want to prove. And what does it mean? It actually means that if we want to prove the first question, we need to prove this question. In order to prove this question, we need to prove the smaller question. And the problems, or the setting of the problem, and the sides of the squares, they get smaller, 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 and smaller. And so basically, if there exists a solution to that problem, that means there exists at least like a minimum solution to that problem, which in other words means that at some point there are like sizes of the square which cannot be reduced anyways. But if we use this logic again, we can get the smaller and smaller and smaller sizes, which basically means that there is no a minimum solution to that problem. And this is a little bit abstract, but if you think about it a little bit, we actually proved the question by contradiction. The most famous technique in proofs, I guess, and I think that's one of the hardest techniques that young mathematicians try to master when they uh, meet some proof-based problems such this one. So I changed my t-shirt, as you can see, and I want to say thank you, John Conway, for the proof I just showed you guys. Because it was the whole idea behind like this video, and the proof itself was taken from the majestic journal called Quant, which is like a best place to learn about like some fancy topics, techniques, to like see a lot of math problems. So guys, go check it out. It's amazing. Why does it matter? Like, what was the point of showing all this? Honestly, for those who are looking for an like something that like would benefit you, I don't think I have a really good answer for that, because it's just like it's just fun, and I think it's not a bad thing, honestly, because when you do stuff for the sake of like loving it or like just enjoying it, it's amazing. It's cool. Math is beautiful. So I guess it's my first video about math, and I think it it is alright. I'll probably make some more, and I hope you enjoyed the video, and it was really nice to filming it and explaining the stuff to you guys. And by the way, sorry for the bad mic. I hope I'll get the better one for the next video. Bye bye.